I'm Anil Kumar. This is a very important trigonometric identity. I've seen it in many test papers. The question is, explore strategies to prove sine square x plus 2 cos x minus 1 over sine square x plus 3 cos x minus 3 equals to cos square x plus cos x divided by minus sine square x. Now if you observe, right hand side could be written in terms of cosine, right? Cos square x plus cos x divided by sine square x could be written as 1 minus cos square x, right? Now since we can write down the right hand side in terms of cosine, it's a good idea to start with the left side, convert sine into cos, right? So I hope the strategy is clear. So we are utilizing the Pythagorean identity, which is sine square x plus cos square x equals to 1 to solve this particular identity, rather prove this particular identity. So we'll begin from the left side, okay? We'll begin from the left side. Sine square x will be written as 1 minus cos square x. So I'm writing sine square x as 1 minus cos square x. So left hand side could be written as 1 minus cos square x, that is for sine square x, okay, plus rest of the terms I'll copy as such. So I'll try to do one thing at a time so that the steps are very clear. So 1 minus cos square x plus 3 cos x minus 3, right? Now 1 minus 1 is 0, so we are left with minus cos square x plus 2 cos x in the numerator. Denominator, we can combine 1 and minus 3, so we have minus cos square x plus 3 cos x, and 1 minus 3 is minus 2. So let's take minus cos x common in the numerator, so we get cos x minus 2. In the denominator, we are looking for a product of minus. This becomes, okay, it's better to take minus common. Let's take minus common first, rewrite this, and then we will factor, okay? I always prefer to have this coefficient positive. That's the whole idea. So if I take minus common, these signs will change, right? So we have 3 cos x plus 2. Now let's rewrite. So the numerator is minus cos x times cos x minus 2. Denominator is minus, we could have cancelled it anyway, cos square x minus 3 cos x plus 2. We are looking for a product of 2, sum of minus 3. So we could write this as cos x 2 times 1, right? And there's some negative 2 times negative 1 will give us plus 2 as product, minus 3 as sum. Is it okay? Yeah. So that is how it is. At this stage, we'll simplify, cancel out the negatives, cancel out this factor, and then we can write the left side as cos x, divided by cos x minus 1. Correct. So that is kind of simplest form we can write the left side as. Now to complicate it, what we can do from here is rationalize and get the answer. So let me show you that part. So now we'll rationalize. So the strategy now being used is rationalize. That is to say, multiply by the conjugate of the denominator, right? And then do the needful. Well, before getting in there, let me show you, at times it is important to start from both the sides. So we can actually simplify the right side, okay? So I'll do that conjugate part in this half. Right hand side for us is cos square x plus cos x over minus sine square x, right? So let's take cos x common. We get cos x common. So we get cos x plus 1 in the numerator and minus, this could be written as 1 minus cos square x. Now, the denominator will factor, okay? Numerator is cos x times cos x plus 1. Denominator will be minus, and this is 1 plus cos x times 1 minus cos x, correct? Difference of squares, 1 square minus cos square x. At this stage, you can cancel these terms. So what do you get? You get cos x over minus 1 minus cos x, correct? Now this could be written as cos x over, now open this bracket, so this becomes positive, so you could write this as cos x minus 1. So what you see here is that we have simplified the right side and left side to exactly the same thing, right? So we have exactly the same thing. Now, as I was saying earlier, you could rationalize. Let me show you that also. Now, this is good enough proof, right? Now, to rationalize, let us see how. We have cos x. Let's again start. So we have done the problem here. We know left side equals to right side. So we have already proven this identity. But let's understand how the left side could be rationalized to get the right side. So we have cos x over cos x minus 1. To rationalize, we have to multiply by the conjugate, that is cos x plus 1, and divide by the same thing, right? So that should give you, in the denominator, cos square x minus 1, and in the numerator, cos x times cos x plus 1. Let us expand this. It gives you cos square x plus cos x, which is the same as this numerator. And cos square x minus 1 is minus sine square x. Is that okay? Cos square x minus 1, you bring it to this side, is minus sine square x. So what I'm trying to say here is that from here, you could have gone to this place, rationalize, and then said this is equals to right hand side. And then you could start from left, reach to the right. So that is another option for you. So either you do this, or you can start from left side and right side, derive at a common point, and say, well, both are equal, and therefore we have proven this particular identity. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.